Tesla delivered nearly 500,000 vehicles in the third quarter of 2025, posting $1.4 billion in net profit despite lower prices and shrinking tax incentives. Far from a slowdown, this feels like the quiet before a massive surge. In Q4, the spotlight turns to Tesla's long-rumored compact EV, now confirmed for a December unveiling with customer deliveries starting in 2026. Prototypes are already testing on California roads. In this breakdown, we explore 7 under-the-radar innovations that could position the upcoming model as Tesla's most affordable and strategically brilliant vehicle yet. Stay until the end, and if you want to be among the first 739 insiders tracking Tesla's next leap, subscribe to AutoIntel and enable notifications. The future starts here. Tesla's R&D labs are putting the finishing touches on aluminum-ion and sodium-ion battery chemistries for the 2026 compact. These alternatives tackle the durability concerns that still linger with lithium cells. Today's lithium packs often drop below 80% capacity after 1,500 to 2,000 cycles as the electrolyte breaks down under heat or fast charging, forming insulating layers on the electrodes that raise resistance and cut range. The new salt-based ionic liquid gel has a boiling point above 250 degrees Celsius, so it resists evaporation, slows harmful film buildup, and stays chemically stable. Fast charging on the supercharger network becomes far less punishing. Paired with refined thermal control and cost discipline, the gel helps the compact strike an ideal price-to-performance balance. The sodium-ion option targets a 10C charge rate, roughly 15 minutes for a full 75 kWh pack, and aims for 300 to 350 miles of range. Lifespan projections reach 3,000 to 5,000 cycles to 80% capacity, translating to 1.4 to 2.8 million kilometers of total driving. Abundant sodium keeps production costs down and shortens the ownership payback window for high-mileage drivers. Meanwhile, aluminum-ion cells carry 3 charges per ion for higher energy density and support 20C charging, about 7 minutes to full. The same 75 kWh pack could deliver 380 to 400 miles. Cycle life stretches to 9,000 or 10,000 with under 10% degradation, yielding over 5.5 million lifetime kilometers. For anyone over 60, this version could be a buy once, drive forever investment. These numbers await full-scale production proof, but synchronized charging hardware, cooling, and protection logic should make the sodium variant a cost-effective all-rounder and the aluminum variant the new benchmark for speed and endurance. Together they erase lithium's longevity worries and anchor the compact as a durable, mass-market EV. The compact launches with Tesla's unboxed manufacturing flow, grouping the body into large modules that assemble in a shorter, linear sequence. The result slashes production costs by roughly 50% and shrinks factory footprint by 40%, laying the economic base for a dramatically lower sticker price. Gigacasting follows. 6,000 to 9,000-ton presses mold front and rear underbody sections in one aluminum pour, replacing 70 stamped parts and hundreds of welds. Each cycle runs 80 to 90 seconds, or 40 to 45 castings an hour, with tight dimensional control that cuts downstream rework. The castings bolt directly to the structural battery pack, turning the floor into a load-bearing spine. The pack wears a 6000 series aluminum alloy, roughly 90% aluminum, 7% silicon, 3% magnesium, heat-treated to T6 for around 450 MPa tensile strength. Target torsional stiffness hits 45,000 Nm per degree, 30% above Model 3 and double a typical compact. Longitudinal bending stiffness lands at 20 to 25 kPa per millimeter, bare body resonance modes start above 35 Hz torsional and 42 to 48 Hz bending, dodging road frequency overlap. Stripped of secondary brackets, the body in white weighs 220 to 240 kg, 25 to 35 kg lighter than conventional builds, trimming energy use 2 to 4% at 100 km per hour and holding cabin noise to 64 to 66 dB. In an SUV-level 37 miles per hour frontal offset, the chassis absorbs and channels energy with controlled deformation, acting like a protective shield. Phantom braking has frustrated countless Tesla drivers, especially on FSD-equipped Model 3 and Y, where sudden stops raise rear-end risks. The compact ships with FSD version 14, rolled out in early October 2025 on an A15 chip packing 10 times more parameters than its predecessor and trained on millions of miles from Tesla's Austin Proving Grounds. 12 360-degree high-resolution cameras, 50% sharper millimeter-wave radar, ultrasonic sensors, and short-range LiDAR, all debuting in an affordable Tesla, feed a triple-layer neural net that cross-checks vision, distance, and predictive logic. Internal testing over 180,000 kilometers this year shows 100% elimination of uncommanded braking, a relief for highway cruises and stop-and-go traffic. Emergency egress has been another pain point. A Bloomberg report logged over 140 cases of stuck doors when power failed, trapping children or seniors in fires or wrecks. The compact redesigns the system with touchless normal operation plus a concealed stainless steel mechanical latch in the trim that needs less than 5 kilograms of force and zero electricity. 10,000 simulated emergencies at Gigafactory Texas yielded 99.8% success, letting occupants exit in 3 to 5 seconds and cutting injury risk up to 40% versus older electronic doors. Insider leaks say Tesla partnered exclusively with Bridgestone on Turanza EV tires sized to 19 inches, larger than the usual 17 or 18, for 15% more road contact and even weight spread. Graphene-infused rubber boosts were resistance 37% over standard compounds. Deep grooves plus graphene's natural water repellency eject snow, mud, or standing water like a lotus leaf, minimizing hydroplaning. Lightweight composite aero caps, inspired by Cybertruck feedback, shave drag 10%, adding 20 to 30 kilometers of range, shielding axles from salt and grime, cutting rust risk 40%, and pushing tire life to 100,000 kilometers with virtually no upkeep. Imagine a $25,000 Class EV riding as smoothly as a luxury sedan 5 times the price. The compact's intelligent adaptive suspension, based on a 2024 Tesla patent, uses electromagnetic dampers that firm or soften in 10 milliseconds, 5 times quicker than air systems. Cameras, radar, and GPS preview the road 10 meters ahead, 0.1 seconds before a bump. The AI raises ride height 5 centimeters and eases damping, dropping vibration from 2.5 Hz to 1 Hz, 60% smoother than conventional setups and on par with an Audi RS7. Above 60 miles per hour it lowers the body 1.5 inches, stiffens for grip, and quiets the cabin up to 25%. Tesla's self-maintenance suite expands the Model Y diagnostic framework with over 200 sensors watching battery, motor, tires, brakes, and more. Real-time data streams to an AI that forecasts where before it turns into breakdowns. Over-the-air updates via 5G or Starlink arrive in 15 to 30 minutes, tweaking software to cut brake wear 10% or refresh terrain maps to preempt trouble. Tesla says OTA fixes have already saved owners $2 billion in repairs from 2020 to 2025. The compact should trim another $1,200 annually per driver in service costs and downtime. These 7 advances paint a clear picture. The compact is not merely another EV, it is Tesla rewriting the rules for the affordable segment. The revolution is just starting. Subscribe to AutoIntel and tap the bell to ride shotgun as daily driving transforms.